Okay, so welcome sa ating synchronous session for today. So, I asked for this meeting such that meron tayong parang introduction sa isa't isa for the course, and then siguro set up yung ground rules for the course, ano yung kailangan gawin, set up our expectations, etc. So, ayun, siguro we can all start by pagpapakilala ko. So, yan, picture ko. Itong picture na lang, no? Huwag na ako mag-video. So, ako si Sir Herlan Benitez. So, ito yung email ko, which supposedly na-receive niyo yung mga emails ko before. And then, where to find me? Yun, pag face-to-face classes, sa room 401 ng Microlab. And ngayon, work from home. If gusto mo talaga akong puntahan, dito ako sa may Pampanga. So, ayun. Ayaw muna bigay yung full address ko. Baka pa anong gawin na. Pero kung papadala niyo ako ng anything, bigay ko sa inyo yung address. And wala pa akong actual official na consultation hours. Ito muna yung nilalagay ko as a placeholder. Since free naman ako from 10 a.m. to 2:30 p.m. from Tuesday to Friday. So, meron pa kasi akong mga regular meetings na hindi pa namin nasa-schedule ng bagong schedule kasi mga regular meetings ko with advisors and other projects. So, subject to, ito na yung most probable. So, mababawasan lang likely. Although, kung mag-email naman kayo, I can, lalo na kung during class hours and walang synchronous session, very, very possible na din na tayo mag-consultation. So yung nagpapatawag lang ako usually ng synchronous session if kailangan natin parang mag-recalibrate para magsabay-sabay tayo, or if medyo na-behind sa schedule yung submissions, usually nagsiset ako ng synchronous session para ma-speed up yung or tumulong sa mga humahabol. So, ayun. So for communication channels for the course, sa course natin itself, it will be primarily sa UVLE. So sa UVLE posted lahat ng course materials, and then siguro puntahan na rin natin yung site. Tama ba? Kita niyo naman sa screen. So kita naman lahat ng nasa screen ko. Or may nakita mo kayong lumulutang na boxes. And someone may nag-thumbs up. So I'm assuming na nakikita niyo yung nakikita ko ngayon, which is yung UVLE. So ayun, meron tayong yung layout niya. So yun, bagong UVLE. Pati kami nangangapapa sa mga settings. So if meron kayong ma-encounter na hindi expected, lalo na sa mga quizzes or sa mga requirements, hindi nyo ma-access, sabihin nyo agad. And so meron tayong general forum dito for announcements, tapos may social forum dito for dun sa mga gustong maghanap ng mga connections. Pero parang wala naman siya. So ito yung initial na onboarding na meeting na dyan na. And then ayun, naka-separate naman into weeks yung ating mga materials. So for example, checking sa course guide and statements and notices. And I think you have to agree to the statement and notices first before ma-access yung iba nating materials. Then, nandito yung course guide, yung original slides, ay yung slides ng onboarding at saka yung recording ng onboarding na nangyari last Tuesday. And then, week 1, nandiyan yung materials. Week 2, actually, nandiyan din. So, ayun, the course will be synchronous. Asynchronous. So it will be at your own pace. So actually, to have more details dun sa pag-handle ng 153, sa daan natin mabilis yung onboarding meeting. So since meron ding dalawa ata hindi naka-attend, I think hopefully okay lang daanan sa inyo ulit. Huh? So yan, so for 153, we are 6 instructors handling 2 to 3 sections each. So ang ginawa namin is per week may naka-assign na isang instructor na gumawa or mag-curate ng materials and materials and assessments. So baka lang ma-off kayo. For example, iba yung format ng current week sa next week. So pero we try our best naman to have a certain standard dun sa mga weeks na. Pero ayun, what is sure naman is for all sections ay ito naman. Lahat ay parang sa EEE 153. So yung title ng 153 is Computer Organization and Embedded Systems. So yung description niya is analysis and design of different aspects of computer organization and their effects in the performance of a system in programming in the performance of a system and in programming using assembly language. So the goals of the course is to explain how a computer works and how different components to a computer affect computer performance and to show how a microprocessor can be used as an alternative to hardwired circuits in the implementation of required electronic functions. So binasa ko lang slide. So ang ibig sabihin lang nito, this course is about computers, pero not in the sense na yung computer, meron siyang CPU, may monitor, may keyboard. But this is ano yung nagpapa-computer sa computer. So yung nasa loob ng CPU, meron tayong motherboard doon and processors. So paano dinedesign yung mga processors? Makikita niyo siya dito and how it and bakit may processor pa, bakit ano yung difference doon sa motherboard, but may mga chips tayo mga dinadagdag, ano yung mga RAM. So usually dito nyo ma-explore kung paano sila nagpa-function and paano sila nakaka-affect ng performance ng system. And what's interesting with EEE 153 is we will not stop at the theoretical side of it. So at the latter part of the course is may experience nyo yung microcontrollers, which is a compact version ng isang CPU or computer na everything na lahat ng nasa loob ng CPU nasa isang chip lang. So medyo niliitan yung scale para mas madali siyang i-observe and parang magkaka-glimpse na kayo on how to program yung computer itself. So parang ngayon siguro yung programming na dinaanan niya is more on making applications. So ngayon ang programming dito is making a computer work. So makikita nyo rin dito paano nagtra-translate to logic gates yung programming niya usually. So yun, couple of terms, computer architecture versus computer organization. So ito yung medyo major topics natin for the course. So computer architecture, yun yung visible sa programmer. And computer organization, siya yung sa computer designer or yung gumagawa ng hardware. So sa architecture, siya yung nagsasabi kung ano yung mga instructions na pwede mong gawin. Si computer organization, siya yung nagsasabi kung paano niya gagawin yung certain operation. So parang architecture is more of the software side, organization is more on the hardware side. And both dadaanan natin sa course na ito. So mode of delivery yun nga, meron tayong uli. Tapos for each week, meron provided na study guide. And dun sa study guide, makikita niyo yung mga materials siya doon. Usually may slides and may videos. So for example, so week 1, kung hindi nyo alam yung gagawin, just look for the file na nakalagay study guide. Then, introduction kung tungkol saan yung gagawin sa week 1, ano yung learning outcomes or objectives, and then yung how you will be assessed for the week. And siguro andun din yung estimated time. So for week 1, estimate is you will need a total of 3 hours. So, although hindi naman yan exact. For example, ito, meron kang video watching na 11 minutes 55 and yung estimated time niya in hours is 30 minutes. So, meron naman yung buffer. So, hindi naman siya eksakto. So, sa mga nagbabalak magmadali, kung gusto nyo tapusin yung course in half the sem, ayun, pwede nyo gamitin yan. And ayun, may kanya-kanya kaming style ng paggawa ng study guide. So for first week is alam ko si Ma'am Vion yun, so more of parang paragraph form siya na kwento and then nag-link na lang doon sa mga kailangan nyo basahin. And then to. Lalagay din naman if yung isang video ay required or supplementary. So yung supplementary video para doon sa mga naghahanap ng extrang malalaman and probably baka makatulong maka-perfect ng quiz. Pero yung sa mga binigay dito, yun lang naman yung required para makapasa at least for the course. Then ayun, iba-iba rin for each, iba-iba rin yung requirements for each week. Pero ayun, among these, for example, ang formative quizzes. So ang formative quizzes ay ungraded na quizzes pero usually gagamitin to nung weak handler to determine or to enable yung mga short quizzes. So parang to check kung nasundan niyo yung nasa slides. So usually in formative quizzes, ang mga tanong is directly lifted sa mga nakalagay sa slides. And yun, bibigay yun before proceeding with yung short quizzes na graded. Yung short quiz, parang naka-assign 10 points per week and for a total of 12 weeks of classes, 120 points yun. So yung short quiz, pwede siyang magkaroon ng additional activity. So kung wala meron simulation in assembly or may kailangan ipa-program in assembly, magiging part siya ng quiz. So parang all-encompassing yung term. So hindi lang siya basta multiple choice or essay, pwedeng merong ipapa-program sa inyo. Then, ayun. And then we have a total of 3 long quizzes for the course and wala nang final exam na covered lahat ng topics. And yung long quizzes naman, nakahati sila yung such a way na related sila. And you'll notice na hindi equal yung number of weeks sa kanila kasi sinundan talaga namin yung coverage ng topics. So for example dito, kung titingnan niyo yung sa course syllabus, yung mas kompletong version ng slides na pinapakita ko kanina, ang first long exam, ay long quiz, is for weeks 1 to 5. So makikita niyo naman yung topics. Of course, week 1, introduction. Week 2 is yung introduction sa assembly. Week 3 is yung single cycle na data path, multi-cycle, and then yung pipeline. So parang related naman lahat yan. So itong instruction set, siya yung mas malapit sa architecture. Itong data path, siya yung mas malapit sa computer organization. And ayun, pagsasamahin lang siya for the first long quiz. Then for the second long quiz, it deals with I/O interfacing, yung memory hierarchy, virtual memory, and page tables and loop buffers, cache. So as you see yung sa second long quiz, more on sa memory siya. Actually, with 3 weeks long talaga siya since meron tayong reading break. Then yung last leg or last section for 153 is yung sa microcontroller na. So yung sa last set of materials is parang dito sa first 2/3 ng course is more on yung the theoretical side of things. Ito yung gusto kong mangyari, ito yung dapat mong gawin. Tapos dito sa dulo meron tayong isang concrete na example nung mga ina-apply itong mga stuff na to sa taas. So yun. Hopefully di kayo masyadong narito sa pag-scroll to. So ayun, ang first weeks natin, ang first weeks 1 to 5, 30 points siya since medyo mas mahaba yung coverage niya compared to the other weeks. And then meron siyang additional na exercise with, I think, Logisim or Digital yata, which is yung bagong software na ginagawa nila. So how will your grade be computed? So yun nga, meron tayong 12 short quizzes worth 120 points in total, and then yung tatlong long quizzes worth 80 points. Tapos, yung total niya may 200 points. So, i-divide mo lang by 200, yun na yung magiging standing mo. And then yung grade conversion natin, dito, standard EEE na 92 pataas yung uno, 60 below yung 3. And usually naman wala na kayong pakita sa gitna. Okay. I think may policies dito on late submission. Oh, dito talaga. So short quizzes will open on the week that is scheduled until the end of the semester. So wala actually deadline yung pagsagot ng quizzes. Although meron tayong limit dun sa attempts. You have 2 attempts for the short quizzes. And then for the long quiz, similarly, it will be open for 2 weeks after niyang ma-release. So differently pala. So yung short quizzes, kahit lahat tapusin niyo at the end of the sem, although I would not recommend that. Masakit siya sa ulo. And siguro kami rin, usually kasi mayroong mga i-check manually sa short quizzes, lalo na kung may essays. So, as much as possible, try niyo silang sagutan agad. May 2 attempts naman kayo. So, if pangit yung first attempt, pwede naman kayo mag-adjust or mag-aral ulit. So for the long quiz, it will be open for 2 weeks after its release. Yung nakalagay na date dito. So for example, si long quiz 2, naka-schedule siya dito sa gitna ni week 9 and week 10. So I think at the end of week 9, you'd expect at November 20, i-release si long quiz 2. And then after 2 weeks, so from November 20 hanggang mga December 6, open siya for you. Now, yung pagka-open naman niya, for example, may nangyari sa inyo and hindi kayo makapag-klase for 2 weeks or hindi kayo makagawa ng requirements for 2 weeks, sabihin niyo lang sa amin agad para alam namin kung paano mag-adjust. Usually, pwede naman namin ipatake sa inyo yung long quiz. Pero siguro if masyado lang matagal, pwede magka-other arrangements tayo. Pero yun, mag-a-adjust naman kami sa situation niyo. As long as sabihin niyo sa amin kung ano yung situation niyo. So, ganun lang naman yung ating kasunduan. Siguro ito, may mga questions dito. So may nagtanong about sudden increase in the difficulty ng course. So medyo expected din naman siya. Kasi usually, kung mangyayari dito, kung ano yung natutunan mo, for example, sa week 3, gagamitin mo siya for week 4, and yung natutunan mo for week 4, gagamitin mo siya sa week 5. So progressively magiging more complex talaga yung topics. And I think that would be true for any course naman. And actually, parang merong ang refresher dito sa gitna kasi pagdating nyo sa microcontrollers, parang magiging basic ulit ng usapan. And then, tsaka magiging complex ulit. Although, ayun, ang discussion naman dito sa microcontroller, it will assume na dinaanan niyo yung previous topics. So, siguro, kung ano, merong kailangan i-discuss dito kay microcontroller na supposedly na-discuss na dito, kung ano dito, the microcontroller uses a virtual memory na may page tables. So, hindi na i-describe sa week 10 paano gumagana yon. Ang sasabihin niya lang, meron siyang gano'n. So, parang gano'n yung story. So, And then yung assessment natin will likely have time limits, pero it will be more than enough. So parang nandun lang yung time limit. Yung time limit na to, siguro kung nag-take ka ng quiz ngayon, dapat in 30 minutes ma-submit mo na siya. So parang, ayun, para rin ma-force kayo na tumapos ng attempt. Kasi meron siguro, yun iba, may anxiety, yung pag hindi pa sigurado sa sagot, hindi mo na magsasubmit ng quiz. So, ito, para lang ma-force lang na masubmit nyo na, para alam nyo na agad if kailangan nyo pang review pa para doon sa next attempt ng quiz nyo. Then, ayun, I think may nag-bring up kasi na prerequisite natin si EEE 143, which is switching theory and digital logic design. So, ayun, since hindi ako naghalo ng 143, so hindi ko actually masyadong alam yung coverage. Pero ang sabi dun sa discussion ng onboarding, sabi nila, Ma'am Tata and Ma'am Gion, yung topics na needed for what from 143 are yung digital logic and yung sequential circuit design. So, kahit hindi nyo natapos yung activities na to sa 143, it should be okay. So, yung lectures naman natin sa 153 are designed na if ever meron man tayong pinuwan topics from 143, may short review about them. So, kaya nyo dapat silang, kaya nyo dapat matake si 153 kahit hindi kayo natapos sa 143. Yung face-to-face classes, so for this sem, we are purely remote. So, yung possibility of face-to-face classes sa second sem pa. Ayun, kayo ngayon, meron ba kayong mga questions about the course? Tulog na yata kayo. Go. Siguro add ko na rin. Yung sa Discord, since tatlong sections yung hinahandle ko, kinombine ko sila into one section, into one server. So, 158THY, 158 WXY, tsaka 158 FXY. So, since I think most naman ng kumukuha ng 153, merong 158 and vice versa. So, ayun, open yung chat, yung discussion for both sections, kahit yung tinitake nyo is just the other section, just the other subject. Pero nga, just be careful lang sa mga policies. So, siguro kung may rechecking or late submission kayo, double check with your actual instructor. Tapos ayun din pala, siguro singit ko na rin for those na nagtitake ng 158, may survey para dun sa distribution ng inyong dev boards. So, papadalan kayo ng dev board and kailangan namin yung address nyo. Kala ko automatically okay. Okay. So may nagtanong na student, Sir, sa quizzes po sa uli, masisave po yung answers namin from the previous attempt. So, ang alam ko, yes, dapat pwede mong i-review yung mga previous answers mo. And, so ito muna yung from uli. I know pag nag-review ka ng answers, may kita mo dapat yung previous answers mo. Just yet not sure kung ibibigay namin or ilalagay na if yung makikita nyo sa review kung kada item may check mark or wala, or kung yung actual score mo lang yung bibigay. So, i-confirm ko lang yun. Pero based kasi sa last year, ang ginagawa namin sa quizzes is makikita mo kung saan ka tama or mali. And then, okay lang sa amin gawin yung before kasi meron kaming ibang questions na nag-iiba at each attempt. So usually, kung may given na, basically nag-iiba yung given for each attempt. So it will really rely doon sa inyong knowledge doon sa paano siya sagutin, hindi kung alam nyo or hindi yung sagot. So, ayun, medyo hindi ko pa I mean, for sure naman may kita nyo dapat yung previous answers no doon sa first attempt nyo before attempting yung second one. Okay, so merong second question nakalagay sa last paragraph ng week 1 study guide na mag-close yung ano. I guess i-bring up ko lang to sa mga handlers. Pero ang rule of thumb naman namin is yung parang itong course guide, siya yung ating contract. So, dapat masundan ito. So, kung nakalagay dito sa ating course syllabus na hanggang end of the semester siya available, that parang ito dapat yung masusunod. So, ayun, maraming salamat sa pag-point out. Actually, hindi ko rin napansin yun. So, ayun, update ko kayo on that kung magko-close nga siya on October 1. Pero in any case naman, at the very least, siguro October 1 naman dapat tapos nyo na siya kasi week 1. And fairly simple naman yung topics niya. So, ayun. Any more questions about the course in general? Any questions tungkol sa akin? I guess what's left is we can end now, or yung other option natin is gusto nyo bandaanan yung week 1 materials as a class. So parang isi-speedrun ko yung mga slides. Gusto nyo ba yun? Or pwede rin natin i-speedrun yung mga videos. Actually, tinry ko panoorin yung mga videos. Sa way ng pagsasalita ni Ma'am Vion, naiintindihan ko pa rin siya kahit naka times 2 yung speed ko. Just sharing. Okay. So, may nagpo-propose ng speedrun. Speedrun ng slides or speedrun natin yung videos? Okay. Siguro let's look at yung slides with notes. Medyo maliit. And so yung for those na would rather go through the slides or the materials themselves, pwede naman na silang mag-leave. Thank you very much for attending. Pero yun nga, merong sa mga gustong sumama sa journey ng pag-speedrun ng slides. Ano ba tayo mag-open? Be supported? Look. Hindi doon. Ito. Ayan, so ang bagal mo load. Bakit siya white? Okay, I think you can work with this. So, EEE 153, Computer Organization and Embedded Systems 1. So, week 1 is all about the introduction to the concepts na dadaanan sa 153. So, which is exactly ito. First, yung computer systems, computer organization, then architecture, and then lastly, embedded systems and microcontrollers. So, computer systems are machines that were invented to help make the thinking work easier and faster. So, usually, na-invento ang computers para mag-compute. So, that part nun is yung pag-solve ng equations, pag-analyze ng information, and pag-track ng information. So, I guess, Nasa Tripoli naman tayo, so I'm pretty sure na alam niyo kung ano ibig sabihin. And then, ayun, computers are all around us. So yung computers natin, hindi lang sila limited sa mga desktop at saka mga laptop. Meron tayong mga computers sa kotse, sa camera, sa phone, sa watch, sa TV, sa microwave. And actually, may computer yung microwave. Kung wari, kahit hindi siya smart microwave, meron niyang computer sa loob. Yung nagde-decide ng timer, lalo na pag digital yung microwave niyo. May internal computer yan, and most likely related siya dito sa nasa dulong topic na embedded systems, na siya yung nagko-conduct. Kunwari, paano nasasabay na yung pag-ikot ng plato ng microwave, sakto siya sa tapos ng timer, sakto siya sa tapos ng radiation. So, parang yung nag-orchestrate nun is a tiny little computer doon sa loob ng microwave. Kasi ayaw naman natin na natapos yung timer pero nandun pa pala yung radiation, hindi pa pala siya safe buksan. And then, another unseen computer ay yung mga tinatawag nating servers or mainframes, na ang primary job is to store information and to upload and download information to other users. So, sabi dito sa slides, merong 4 major tasks yung isang computer. First is to get input from its surroundings or accept information from other sources, outside sources, and then store that information. And then what it can do is process that information na nakastore, and possibly pati yung information na pumapasok pa lang, pwede. So i-manipulate niya yung nakastore na data in order to generate a certain output for the environment or for its friends. So yun yung major task ng isang computer: input, store, process, and output. Now, kumbaga meron tayong 2 parts of our computer. So the first part is yung hardware, so yung physical components ng ating computer, where the actual data and electrical signals pass through. And then we have what is called software, which is the set of instructions that is read by the computer to control its hardware to generate or para magawa yung certain things. So pwede siya makita yung tasks nandito. So usually, si input device, si memory, processor, and output device are all hardware, pero what makes them work together is yung software. So yan, input devices, alam niyo siguro yan, keyboard, mouse, keypad, game controller, mic, and other sensors, webcams. So may papasok na data sa input, and then matatranslate siya to binary information, and siya yung masastore. Output devices, siya yung mga display, speakers, printers, robot arms, and after ma-process ng information, lalabas as digital data, and then yung output natin, siya yung magko-convert from that digital data to what we can experience sa real world. So the central processing unit is an electronic circuit that contains many circuit blocks that perform different operations that can manipulate data. So usually yun yung processor part natin dyan. And then, ayan, ang pumapasok sa processor ay data and instructions. So, yung data, yung instructions, siya yung magsasabi kay processor kung ano yung gagawin sa data na nasa loob. So, inside the processor, you would usually find a control unit and then some registers. So, ang registers ay internal memory na very, very fast, na as in relatively fast compared sa other forms of memory. And then, ayan, yun yung control unit. Registers is temporary data sa loob ng processor. And then yung arithmetic and logic unit, siya yung may functional blocks like adders, multipliers, and for sa mga specialized na processors, meron pa yung mga FFT sa loob na block. Tapos, ayun, so ito yung processor. So, yung memory naman natin is of course, alam niyo naman, memory stores information. So meron dalawang types of memory. Volatile memory, which loses its contents when it loses power. So bakit bakit ka gagamit ng memory na nakakalimot pag namamatay? So gumagamit ka ng volatile memory because it operates faster than yung non-volatile memory. Kaya ito, ang volatile memory, siya yung primary storage or main memory ng computers talaga. So sila yung mga programs mo na ginagamit mo specifically right now. So nilalagay mo siya sa volatile memory para kasi if you run your programs na nakastore doon sa non-volatile and slow memory, mabagal ka. Pero yun, we still keep non-volatile memory kasi yun nga, ang major drawback ng volatile is it loses its contents. So si non-volatile memory, siya naman yung mabagal pero hindi siya nakakalimot. So, yun. Pag yung memory nakastore sa computer is just zeros and one, pero meron tayong address na associated with it. So, hindi naman siya puro ones and zeros lang na nakastore. So, meron tayong certain addressing system para alam natin kung saan maghahanap ng certain piece of memory. So, ayun. So yung data na nasa memory natin can actually come from an input device or the result of the processor na later na pupunta sa output device. So para maglagay ng data sa memory, either from input or your internal processor. So hindi lang siya sa processor itself. And actually, yung paglagay ng input sa memory itself is a type of input management and direct memory access, which we will learn later on in this course. So yung software natin actually, it's a collection of instructions lang talaga and nakastore din siya sa memory natin. So, so for the software na nilalagay, yung tinatawag natin assembly, siya yung so if yung instructions natin is just a collection of ones and zeros, paano natin nasasabi kung ano yung ginagawa ng instruction talaga? So doon ginawa yung assembly na language, wherein yung mga zeros and ones na to, yung mga string of information na yan, nakakonvert or actually the other way around. Kung meron tayong human readable na instruction, multiply or add, and then mako-convert siya to its binary machine language equivalent. So yun yung assembly code, yung kaya mong i-convert from assembly to binary machine language. And then ayun, pagdating naman sa higher level languages, parang it's a step away from yung ating assembly. So for example, sa C or sa C++ or even sa mga compiled na languages, ang ginagawa is yung high-level na language, ko-convert na to assembly, and then si assembly is dadaan pa sa assembler at magiging machine language. So bakit hindi natin diretso yung high-level programming language dito sa binary machine language? So mahirap kasi siyang gawin. Hindi 1:1 yung correspondence. So for example, dito sa high-level language, meron tayong 1, 2, 3, 4 lines of code. Pero makikita mo dito sa assembly language natin is 1, 2, 3, 4, 5, 6, 7, 8 lines of code. Itong 8 lines of code na to correspond to one line of binary or one stream of binary information. So, si assembly language may 1:1 na correspondence. So, yung isang line ng assembly language program is one line in memory. So, very restrictive siya in a sense na yung mga operations natin dito, kailangan nga directly sila matra-translate into machine language. And since very limiting yun, kaya gumawa pa ng high-level language. So, hopefully ma-appreciate nyo. So, yung next section dito is about computer organization versus computer architecture. So, I think what this slide tells us is kung ikaw ay software person, ang ginagalawan mo is yung application mo, yung operating system mo, yung compiler, and yung assembler. If you are a hardware person, ang things of interest sa'yo is yung processor, memory, I/O devices, and yung data path control. So, paano sila mag-work together? So, doon dumadating si computer architecture or yung instruction set architecture na tinatawag. So, computer architecture refers to the computer's attributes that are visible to a programmer. So, instruction set or yung assembly instructions, data bit widths. Ayan. So, lahat ng yan is specified by the computer architecture. So, yung nga, sinasagot niya, is there a multiply function? What other functions are available? And then computer organization refers to the organization of the actual circuits and yung other hardware to implement the features ng ating architecture. So usually magsiset ka ng certain architecture and then si computer organization, siya yung mag-a-adjust para ma-accommodate yung gustong mangyari ni architecture. So kung wala sabi ni architecture, gusto ko ng multiply na function. So si computer organization is gagawa siya ng circuit para gumawa noong multiply na function. So pag sabi ni architecture, kailangan niya ng FFT, si computer organization yung problema kung paano siya gagawa ng FFT block dun sa loob ng computer. So ayun, may table lang din dito. It's very helpful. So anong ginagawa? Architecture. Paano niya ginagawa? Organization. So usually nga, muna si architecture, tapos si organization is yung mag-a-adapt doon sa hinihingi ng architecture. So si architecture realizes yung computer's hardware. What that means is kung ano yung architecture na pinili mo, usually siya yung magdetermine kung ano yung hardware na kailangan. And then, so kung pag binago mo si architecture, it means na mag-iiba yung hardware. Si computer organization, it realizes the computer's performance like speed and power consumption. So pag binago mo si computer organization, magbabago yung performance niya, like speed and power consumption, as long as na-attain mo pa rin yung requirements ng architecture. Then, computer architecture includes logical functions, like instructions, registers, and data types and addressing modes. And then si computer organization siya sa physical units. So sa actual circuits, yung mga logic gates mo sa loob ng computer. Then lastly, yung architecture, tinatawag siyang instruction set architecture. Since the computer architecture parang describes what possible instructions yung kailangan niya. And then si computer organization, frequently called microarchitecture. Pero actually, hindi ako ganun ka-familiar sa term na to. So, ayun. So notable architectures is yung ARM, na common sa mobile devices. Yung x86, pag tinitingnan niyo yung program files niya sa Windows, usually may ganyan. So, usually galing to sa Intel, ang alam ko. Okay, Intel 8086. And then si MIPS, yung common sa mga microcontroller to. Ayan, microprocessor without interlock time stages. So yan. So microcontrollers and other embedded devices. And then meron itong bago is si RISC-V or RISC-V. So, ayan, architecture din siya ng open source siya. So, walang bayad. So, to classify architectures, merong several ways. So, by yung operands, by memory, by complexity, at saka Flynn's classification, which is, I think, yung about sa parallelization. So, classification by instruction operands. So, merong memory to memory, which means yung per instruction, diretso ka sa memory nag-access. Tapos, merong register to memory na, ayan, 2 operands per instruction, only 1 operand can access memory. Ayan. And then, itong load store architecture wherein hiwalay yung mga commands na nag-load and store sa memory and hiwalay yung commands na nag-operate on those operands. Then, accumulator-based is meron siyang 1 operand siya na operation. And actually, nakastore lang sa isang register, accumulator. yung mga results ng operation. Then, classification by memory structure. Si Von Neumann, siya yung sa memory, nandun lahat. Nandun yung data and instruction. And then, special distinction din na isang bus lang, si I/O, si processor, and si memory. So, pag si I/O gusto niyang kumausap kay memory, hindi pwedeng kausapin ni processor si memory. And then, pag well, actually, si processor usually yung boss dito. So, pag si processor gusto niyang mag-access ng memory, hindi siya makaka-access ng I/O. Si processor gusto niya mag-process ng I/O, hindi siya makaka-pasok sa memory. So, ayun, si Von Neumann, siya yung pinakasimple sa mga classifications. And isang bus lang yung ginagamit. So, yun yung parang tinatawag na bottleneck. Dito naman sa susunod, which is yung Harvard architecture, nakahiwalay yung instructions and yung data. So, ayun, pwede si processor mag-access sabay ng instructions at ng data at the same time. And kaya niya rin mag-access ng I/O and data at the same time. So, ayun, yun yung main pro niya. Yung mga disadvantage niya is, since mas madami tayong connections, mas madaming area yan sa chip. Actually, pag ginawa mo siya, mas madaming wires yung kailangan mo. And yung control unit mo is magiging complex. And another thing, kung wari, sa instruction memory, hindi naman siya puno, pero sa data memory, punong-puno na, hindi ka pwedeng maglipat from data to instruction or instruction to data. So, dito kasi sa Von Neumann, si memory, as long as may space pa sa memory, pwede ka pong magsaksak ng instructions or pwede ka pong magsaksak ng data. As long as di pa siya puno. Ito, kahit mapuno lang yung isa, hindi ka na makakapagdagdag doon kahit walang naman yung kabila. So, yun yung parang ina-address nitong mga sumusunod na types, which is actually modified Harvard. So, dito sa una is merong separate cache for data and instruction. So, yung cache is a smaller and faster memory that contains the most recent information. So, the main memory still contains both data and instruction. So, usually, yung gagawin lang nito, may isang memory for both data and instructions, and ang ginagawa ni processor is nililipat niya into a data and instruction cache para ma-achieve yung Harvard na architecture without yung drawback na pag napuno yung isa. Yung iba naman ang ginagawa nila, yung mga instruction, yung instruction memory pwedeng gamitin as data or vice versa, yung data memory pwedeng gamitin as instructions. Then next is yung tinatawag na classification by complexity. So yung complex instruction set computers or CISC aims to reduce the program size by using complex instructions. So mas complex na instructions yung kaya niyang gawin, pero mas complex din siya i-implement. Sa reduced instruction set, yun, simple lahat ng instructions. So simple lang din yung pagka-implement niya. So, anong mangyayari doon? So, sa CISC, madami siyang instructions na kayang implement. Si RISC, fewer number of instructions. Si CISC naman, pero yun yung number of instructions. Yung actual program mo, usually, mas maliit siya kay CISC and mas konti yung RAM na kailangan mo since mas maikli yung mga program. Sa RISC naman, mas malaki yung program size mo. So usually, one CISC instruction might constitute to many RISC instructions. So parang high level, low level siya kumbaga. Pero kahit medyo high level si CISC, na-implement pa rin naman nila. Ayun, sa CISC naman, yung instructions natin have variable length and usually more than one word yung size. Tapos, si RISC yun, since konti lang naman yung instructions, mas konti yung mga kailangan mo information to give per instruction. Then yun pag complex yung decoding. Pag reduced, magiging simple siya and simple yung decoding. Then, si CISC usually sa memory-to-memory or register-to-memory architecture, and then si RISC sa load store architecture. Si multiple clock cycles per instruction. Si kaya niya magsabay ng mga instructions per clock cycle. And then, si gumagamit siya ng transistors for storing complex instructions. And then si gagamit siya ng transistors para sa mga registers. So yan, parang meron tayong performance equation dito na yung time natin per program. So time per cycle, cycles per instruction, and instructions per program. So si ang gusto niyang mangyari is taasan yung number, babaan yung number ng instructions per program while sacrificing yung cycles per instruction. Tapos balik to naman si list. So tinataasan natin, tumataas yung instructions per program pero yung cycles per instruction bumababa. And since yun nga, isa din sa major drawback ni RISC is mas malaki yung RAM na kailangan niya kasi mas malaki yung programs na. Medyo naging less of a cost siya ngayon since mas nagmumura ang RAM. Then si Flynn's classification, depende siya sa number of instructions and yung data streams na kaya pagsabay-sabay. So single instruction, multiple data, multiple instruction, single data, and then multiple. So ang magiging focus dito sa next few slides is yung MIPS architecture. Actually, isang slide lang pala. Kasi ito yung gagamitin ng microcontroller natin na i-represent sa course. So it implements a load store RISC architecture. Was developed as part of a very large-scale integration research program at Stanford University. So meron siyang a total of 111 instructions, which can be represented by 32 bits and can be processed in a single clock cycle. So MIPS processors usually use what is called a pipeline para maging efficient siya sa pag-process ng information. So kung nakita niyo sa course syllabus kanina, meron tayong journey from single cycle to multi-cycle to pipeline na data path. So that is because yung nga, parang nagbe-build up tayo dito sa MIPS architecture na gagamitin sa latter part ng course. So yung last section naman natin dito is embedded systems and microcontrollers. So embedded systems is a type of computer system that does specific functions for a specific application. So yung keyword dito is yung specific. Kasi yung usual computers mo, like the laptops and your computers, they are not designed for a specific application, pero designed sila to handle multiple and several functions and applications. So isang embedded system, naka-design siya to perform a specific function or a specific application. And usually part sila ng isang larger na system. So, ayun, why talk about embedded systems? So, lalo na ngayon, isang malaking buzzword yung IoT. So, yung mga smart appliances, usually lahat yan may mga smart ay merong embedded systems sa loob. Then, merong mga types din ng embedded systems. Merong mga standalone. So, as the name suggests, standalone, kahit siya lang mag-isa. And then, real-time embedded systems is yung kanyang time specificity. So, kung kailangan specific yung timing niya. So, meron tayong soft real-time embedded systems, kunwari for multimedia and telephone. So, pag meron kang kausap, kung medyo nag-miss ng timing, okay lang din naman. Wag lang ganun kadalas. So, okay lang mag-miss, pero pag nag-miss ng sobrang dami, pangit na yung result. Pero wala namang masama mangyayari. Like, hindi na kayo magkakaintindihan. That is in contrast dito sa susunod na real-time embedded systems na kailangan on the dot sila mag-trigger. Like yung airbag system, military equipment, medical equipment, tsaka navigation. So, kailangan accurate sila and mabilis. Kasi if hindi, ayan, pag na-late yung airbag mo, ba't pa nag-airbag? So, if masyado siya maaga, ganun naman siya. So, real time. Then, next is yung networked embedded systems, which is yung embedded systems na naka-connect sa network. Kaya, network. So, with the Internet of Things, siya yung isa sa mga fastest growing area in embedded system applications. Then next is yung mobile embedded systems. So itong mga embedded systems na to, usually naka-battery lang and kaya mong dalhin wherever. So hindi siya kailangan naka-plug in sa socket. So ano yung mga mahalagang bagay sa embedded systems? So since kailangan specific or designed sila to be a specific or to do a specific function for a specific application, kailangan low power, low cost, and maliit siya, and easy to use. So lahat yan characteristics ng something na gusto mong, parang very cheap, low cost way to implement something. So, and then for real-time embedded systems, dapat mabilis and high accuracy. Then, for all embedded systems, kailangan stable and reliable over a long period of time. So, ayaw naman natin na pinapalitan natin sila every now and then. So, components for embedded systems, ayan, actually, meron yata tayong halos tigi-tigisang meeting on this sa I/Os, ADC, timer, and communication ports doon sa latter part ng course natin. Mga components of an embedded system. So, anong difference ng embedded system sa microcontroller? So, a microcontroller is a way to implement a embedded system. So, a microcontroller is a single integrated circuit that is typically used for a specific application and designed to implement a certain task. So, embedded system talaga yung dating niya. And then, sa embedded system kasi, hindi naman required na microcontroller yung gamitin. Pwede kang gumamit ng processors and other peripherals. Pero bakit mo mas gustong gumamit ng microcontroller? Kasi, nasa kanya na ang lahat. So, sa isang microcontroller, usually, nandyan na yung communication peripherals mo, dyan ay meron ka ng additional memory, meron kang input-output ports, meron kang mga timing ports, meron ka na ng A to D converter sa loob. So sa microprocessor, usually ang kwento dito, ang general gist is mas madaming kayang gawin si microprocessor, pero si microcontroller is mas maliit, mas mura, and ayun, pagka may microcontroller ka, usually siya lang yung kailangan mo. Konting peripherals na lang, okay ka na. Si microprocessor is, usually si microprocessor nandito lang siya sa CPU and sa interrupts. And then, kailangan mong hiwalay na peripheral para dito. Bibili ka pa ng timer, bibili ka pa ng A to D, and bibili ka pa ng memory. So, si microcontroller, andyan na sa kanya lahat in one chip. Kaya yung usually story dito, yun nga, mas madaming kayang gawin to, pero mas maliit to. Kaya mo isiksik kahit saan. So, ayun, some popular microcontrollers. So, pick yung gagamitin natin, Peripheral Interface Controller by Microchip. So, ayun, computer robotics. So, kung gusto niyo pumunta doon. Then, meron ARM, Advanced RISC Machine. So, most popular in digital embedded systems and instrumentation, control systems, wireless networks. 8051 by Intel at saka by Texas Instruments. And that's it. Yun lang naman. So, yun ang overview ng ating course talaga actually. So, parang medyo nag-expand lang tayo ng konti sa mga individual points natin dito sa course syllabus. So, ayun. Ayun, wala pang 5:30. Ayun. So, any questions ba tungkol doon? So, medyo mabilis. Speedrun nga, di ba? May questions ba so far? So, mukhang wala namang kasing equations, wala namang ano. Usually, pag meron kang gusto i-clarify, searchable naman sa internet yan. So, more on definitions naman kasi to. So, I think, madali, kung meron man hindi ganun ka-clear, madali lang siyang i-look up sa internet. And, ayun, meron naman tayong mga references na nandito rin sa syllabus. Ito. So if hindi kayo sure sa definition ng isang bagay, usually nandyan sa reference yun. If kailangan nyo ng further na explanation, you can always contact us. So kung wari ayaw nyo sa akin, pwede naman kay Sir Darby, pwede kay Sir Mark, kay Sir Snap, kay Ma'am Yon, or Ma'am Tata. Nasa i-keep nyo na lang sa amin, anim. Huwag na tayo magtanong pa sa iba. Hindi nag-handle ng 156 para coordinated din. So, ayun. And hopefully, nakasama na kayo sa Discord. So, if meron pa kayong mga questions, dito yung 153 chat, or since kung week 1 specific, dito na sa weeks 1 to 5 na question. And thank you very much for attending this session. Hopefully, na-enjoy niyo yung speedrun ko. Hindi ko gina-guarantee na papasa na kayo sa quiz with that, pero sana may natutunan kayo. And thank you very much, and then I'll see you next time. So next week pala, hindi pa ako sure. Probably, mukhang hindi pa naman yata kailangan ng synchronous session ulit. So, ang pinaka-goal talaga for the synchronous session is yung may introduce lang tayo sa isa't isa. Kahit hindi ko kayo pinag-introduce sa akin. Sige, kaya ko naman. Yeah, pictures naman kayo. Sige. Okay. So, till next time. Bye-bye.